We are discussing the UML, that is the Unified Modeling Language in software engineering. So, what is UML? UML is a standard language for specifying, for visualizing, for constructing, and documenting the artifacts of software system. UML is different from the programming languages like Java, C++, but tools can be used to generate code in various languages using UML diagrams. Actually, UML is a pictorial language used to make software blueprints. The idea or the aim of UML, because we know that the picture is worth 1,000 words, this absolutely fits while we are discussing the UML. So UML diagrams are not only for developers, but also for the users, business users, common people, anybody interested to understand the system. So it must be clear that UML is not a development method, rather, it accompanies the processes to make a successful system. The goal of UML can be defined as a simple modeling mechanism to model all possible practical systems in today's complex environment. What are the building blocks? Now we'll see the UML building blocks, which are things, relationship, diagram. What are things? Things are the most important building blocks of UML, and things can be your structural, behavioral, and grouping. So things can be structural, behavioral, and grouping, annotational, right? And the structural things, we start with a class. Okay, we are divided into three. Now let us discuss them one by one. Class represents the set of objects having the similar responsibilities. Class will have attributes and operation on these attributes. Then we have interface. Interface defines the set of operation which specify the responsibility of a class. Interface. Then the node. Node, it can be defined as a physical element that exists at runtime. Collaboration. Collaboration defines the interaction among the elements. Use case. Use case represents a set of actions which will be performed by a system for a specific goal or an actor. Component. Component describes the physical part of a system. This is a physical part, two rectangles inside a rectangle or partially inside the rectangle. Then behavioral things. This consists of dynamic parts. We have seen the static parts. These are the dynamic parts of UML models. What are the behavioral things? Interaction. Interaction is defined as the behavior that consists of a group of message exchange among the elements to accomplish a specific task. The state machine means the state machine is useful when the state of an object in its real life is important. It defines the sequence of states. An object goes through the response and responds to the events. So events are external factors responsible for state change. These events they will result in the state change. Then grouping things. Grouping things can be defined as a mechanism to group elements of UML together. So there is only one grouping thing available, that is the package. So package is the only one grouping thing available for gathering the structural and behavioral things inside it. This is the package. Annotational things. These can be defined as a mechanism to capture the remarks, descriptions, and comments of UML model elements. And you have to note this note is the only one annotational things available. Note. This is a note shown by a flipped rectangle, a flipped corner of the rectangle to be more precise. A note is used to render comments, constraints, etc. of an UML element. Then comes the relationship. Relationship is one of the most important building blocks of UML. It shows how elements are associated with each other, and their association describes the functionality of an application. So there are four kinds of relationship available. Dependency. What is dependency? It is a relationship between two things in which change in one element will also affect the another. Dependency. Association. Association is basically a set of links that connects elements of an UML model. It also describes how many objects are taking part in that relationship. Association. Then generalization. Generalization. Now this can be defined as relationship which connects a specialized element into a generalized element. It basically describes the inheritance relationship in the world of objects. Realization. Realization can be defined as a relationship in which two elements are connected. One element describes some responsibility which is not implemented, and the other once implement them. You have to realize it, means implement it. This relationship exists in case of the interfaces. Diagrams now. UML diagrams, they are the ultimate output of the entire discussion. All the element relationships are used to make a complete UML diagram, and the diagram represents the system. UML includes major 9 diagrams. They can be categorized. First we talk about the structural diagrams. So they are class diagrams, object diagrams, component diagrams, deployment diagrams. What about the behavioral diagrams? Means some dynamicity is there. Use case diagram, sequence diagram, collaboration diagram, state diagram, and activity diagram. These are 4 structural diagrams, and these are another 5 behavioral diagrams. We'll start with the class diagram. A class diagram are widely used to describe the type of objects in a system and their relationship. Class diagram will consist of classes, the interfaces, the associations, and the collaboration. Classes are composed of 3 things. We know that the name of the class, the attributes, and the operations. We have an example of a class. This is a class name, say a customer. These are the attribute of this class customer, which is a name with data type as string, address as string, and the operations, that is the credit rating. So class diagrams also display relationships such as containment, the inheritance, and association, and others. With this, these are say 2 classes. Now we want to see how they both are associated. What is the multiplicity? Means this is many valued, this is mandatory. Okay. There are another common relationship in the class, which is a generalization. So a generalization is used when 2 classes are similar but have some differences. We'll see. Generalization means these two can be called specific, but they can be generalized as this class. So this is a generalized class which can be embedded or inherited by these 2. So this is generalized class. Customer. It can be a corporate customer. It can be a customer. Can be a personal customer. This is generalization. So when to use class diagrams? Class diagrams are used in nearly all object-oriented software designs. We use them to describe the classes of the system and their relationship to each other, and how to draw this class diagram. These are some of the most difficult UML diagrams to draw actually, because from here everything starts. To draw detailed and useful diagrams, a person would have to study UML and object-oriented principle for a long time. So this will give a very high level of overview of the process. Object diagram. Object diagram can be described as an instance of a class diagram. So these diagrams are more close to real-life scenarios where we implement a system. And these object diagrams are a set of objects and their relationship, just like class diagrams, and they also represent the static view of the system. The usage of these object diagrams is similar to class diagrams, but they are used to build prototype of the system from practical perspective. Then comes the component diagram. The component diagram represents a set of components and their relationship. This component consists of classes, the interfaces, and the collaborations. So the component diagram represents the implementation view of a system. And during design phase, software artifacts like the classes and the interface of a system, they are arranged in different groupings depending upon their relationship. And now these groups are known as the components. And component diagrams are used to visualize the implementation. Component diagrams. Deployment diagrams. These are a set of nodes and their relationship. These nodes are physical entities where components are going to be employed. Okay, they are going to be employed or deployed. So deployment diagrams are used for visualizing deployment view of a system, and this is generally used by deployment team. And you need to understand that this certain diagrams, they are defined or they are used only in the later of the system. Okay. Use case diagram. So use case is a set of scenarios that describe an interaction between a user or an actor and a system. So the use case diagram displays the relationship among the actors and use cases. The two main components of a use case diagram are use cases and actors. So here is an actor, here is a use case. An actor is representing a user or another system that will interact with the system we are modeling. So a use case is an external view of the system that represents some action the user might perform in order to complete a task. So when to use these use case diagrams? Use cases are used in almost every project. These are helpful in exposing requirements and planning the project. During the initial stage of the project, most use cases should be defined, but as project continues, more might, or you can make it more visible. So how to draw use cases diagram? Use cases are relatively easy UML diagram to draw, but this is a very simplified example. Start by listening to a sequence of steps a user might take in order to complete an action. Browse, catalog, select items. Say, let us take an example. Call sales representative, supply shipping information, supply payment information, receive confirmation number from the salesperson. So these steps would generate this simple case diagram. Like a customer will browse first, second, third, fourth, fifth. This is a very simplest diagram which we can think of. Then comes the sequence diagram. A sequence diagram is an interaction diagram, and from the name of this it is clear that the diagram deals with some sequences, one by one, step by step, which are the sequence of messages flowing from one object to another. So interaction among the components of a system is very important from implementation and execution perspective. So sequence diagram is used to visualize the sequence of calls in a system to perform a specific functionality. Collaboration diagram. This is another form of interaction diagram. Now here it represents the structural organization of a system and the messages which are sent and received. So structural organization consists of the object and the links, and the purpose of this collaboration diagram is similar to sequence diagram, but the specific purpose of collaboration diagram is to visualize the organization of objects and their interaction. State diagram. These are used to describe the behavior of a system. State diagrams describe all the possible states of an object as event occurs, some event which gives rise to a state. So each diagram usually represents object of a single class and track the different state of its objects through the system. When to use the state diagrams? Use state diagrams to demonstrate the behavior of an object through many use cases of the system. Only use state diagrams for classes where it is necessary to understand the behavior of the object through the entire system. And not all classes will require a state diagram, and state diagrams are not useful for describing the collaboration of all objects in a use case. How to draw? State diagrams have very few elements. The basic elements are rounded box representing the state of the object and arrows indicating the transition to the next state. So the activity section of the state symbol will depict what activities the object will be doing while it is in this state. This is the activity, this is the transition. Okay, the state name and the action. So all state diagrams being with the initial state of the object. This is the state of the object when it is created. After the initial state of the object begins changing state, the conditions based on the activities can determine what the next state the object transitions do. This is the initial state. This is state 1. Say we have some condition. Then with certain condition it will transit to state 3. With another condition this will transit to state 2. Activity diagrams. These activity diagrams describe the workflow behavior of a system. Activity diagrams are similar to the state diagrams because entities are the state of doing something. So the diagrams describe the state of activities by showing the sequence of activities performed. Activity diagrams can show activities that are conditional or parallel. So when to use activity diagrams? This should be used in conjunction with other modeling techniques such as interaction diagrams and the state diagrams. The main reason of using this activity diagram is to model the workflow behind the system being designed. Activity diagrams are also useful for analyzing a use case by describing what actions need to take place and when they should occur, describing a complicated sequential algorithm and modeling application with parallel processes. How to draw? Activity diagram shows the flow of activities through the system, and diagrams are read from top to bottom, and they have branches and forks to describe the condition and parallel activities also. So a fork is used when multiple activities are occurring at the same time, And we'll see a diagram just now. It shows a for activity 1. So this indicates that both activity 2 and 3 are occurring at the same time. After activity, there is a branch. The branch describes what activities will take place based on the set of conditions. And all branches at some point are followed by a merge to indicate the end of conditional behavior started by that branch. After the merge or all of the parallel activities, this must be combined to join before transitioning or transforming into a final activity state. This is what we are talking about. This is the start, this is activity 1. Now this is fork, means it gives rise to activity 2, activity 3, and this is the branching. Okay, the branching showed by the diamond. This goes to activity 4, activity 5, then we need to merge them, and then to join, and finally activity 6 with an end. Please observe this start and end symbols. So this was about the UML diagrams. Thank you so much. Take care.